Hello, my name is Ethan Airwood, and I am going to demonstrate my network programming final project. It is called MeChat. It is a group chat over TCP that utilizes channels as well as a basic authentication system with a intelligent user state. So to start off, the server is written in JavaScript, so we'll start that with Node. The client is written in Java, so we'll run Java threaded client. And we'll start by connecting to the server itself. You'll notice that the server client 0, socket connection successful. So let's go ahead and run the same command on this terminal. And you'll see client 1. And then finally, localhost 8124.1012. So this is the port number, this is the IP address, this is all running locally. Now let's show about sort of what the server has to offer. So you can run the help command, and the help command will list all of the different commands available to you. So we'll start by running the help list command. It says the list command is for listing channels on the server or users in a channel. Syntax, list, users, or channel. We can also run help and let's say new. The new command is for creating a new user. Syntax, new, username, password. You'll also see on the left here, the server is logging everything we're doing. This is a way that we can use to debug the application when something goes wrong. So this tells us that client 0 executed command help with arguments none. This was that first command we wrote in pink. The second logging was command help with arguments list. You can see that here. And then lastly, help with arguments new. You can see that one here. Now, the normal flow is when you're at this state, you're not authenticated, you really can't do much. You can create a new user, you can log into a user, you can exit the application, and you can run the help command. Some things you can't do is chat yet, but let's try it. So if we write chat hello, it'll say invalid command, not authenticated yet. Try using login. So let's go ahead and do that. Let's log in, and we'll just run it. We're missing arguments. So this app is very intuitive, and it's meant to help the user use it. So here, how do we use the login command? Let's run help login. Now we know that we need to pass in a username and password. So let's just run login Ethan ABC123. It looks like our username that we passed in does not exist. Let's go ahead and create our first user. We know the new command takes a username and a password. The new user was successfully created. Log into your new account with the login command. So let's try that again. Login Ethan ABC123. Logged in successfully. Now we have a couple more things we can do. We still can't chat yet, and I can demonstrate that by writing chat hello. It says we're not connected to a channel. Let's go ahead and list all the available channels. We have 4 of them. Let's connect to the foo channel. We're in here. Now let's see how many users. So we list users. It's only me. I'm going to take a quick moment, and we're going to create user accounts and sign in on the other 2 clients that we have connected. We'll run new Matt123ABC, log in, and then let's list channels one more time, and let's connect to the foo channel. You'll notice first on the right here, it says Matt has joined the chat. Additionally, from Matt's terminal, if we write list users, it'll show that the Ethan user from the top right terminal is also in here. Let's send our first chat message. And instantaneously, it is delivered to the client over here. Now let's write back. You can see it comes over here. Now, let's sign in on our third user account. So we're going to create a new user, and this one will be XYZ. We'll log in to the Jack account, and then let's connect to a different channel. Let's connect to the bar channel. We're going to list the users, and it's just Jack. We write a chat message, it's sent, but there's no one to receive it. Let's disconnect from the bar channel. They're running the disconnect command. And then we know we've disconnected because if I write chat hi, it says we're not inside a channel. So then let's connect to the foo channel. you'll see on both terminals, Jack has connected to chat on here and Jack has chatted on here. Now let's send a message. Hi, everyone. And on both terminals, Jack receives a message. Similarly, Matt can send a new message, chat. Hi, Jack. I'm Matt. And it appears on Jack's terminal as well as Ethan's. Now, Ethan's done with the chat, so he's going to go ahead and leave the chat. He's going to disconnect. You'll notice that Ethan has left chat on both other terminals. This is intuitive, and because we can actually still run list users, and we'll see that Ethan is no longer within the user list for this channel. Now we can try a different command. Ethan is still connected, is disconnected, but is still logged in. So now let's log out from the Jack account, logging out. When you log out, it also disconnects you from the channel. So when you're in here, it's just Matt in here. Jack is now logged out. So Jack cannot do things like connect yet, or better yet, they can't list channels because they're not authenticated. Let's sign back in. Log in, Jack, XYZ. Boom, we're logged in. Now we can list channels. We can connect to the food channel again, and we can send a new message. Chat, hi again. The last command I'd like to show is the exit command. So from Jack's terminal, he writes exit. This completely exits MeChat. He is now no longer logged in, and he is now no longer connected. So he cannot do any more operations. And that is all that I have to show for the demonstration of the application. Now let me jump into some of the code. So the JavaScript server operates pretty simply. We have a couple maps and stores. The user store is used for authentication. The client map is used to store the clients, and the channel map is used to store the channels. We have a broadcast function, which will broadcast a user's message to all the other clients in the list. We have a channel broadcast function, which will broadcast a message to the entire channel, regardless of the users in it. We can see this in action when the broadcast method is used when someone sends a chat message, and it comes by as their username in blue and the message in white. The channel broadcast method is used when the server is sending a general announcement, such as someone has left or joined the chat. I have a generator function here that will yield new IDs for incrementally through the instantiation of the server. What this means is that when we track the clients by their numeric ID, there will be no conflict as that ID generation is always incrementing and never decrementing, which means that there will never be a conflict. We're using a basic class structure to store some of the information about the client itself. So we have the raw socket client, the ID, if it's been authenticated, their username, and the channel name that they're a part of. We have a server log function that I have currently commented out a larger, more verbose logging format, which stores additional information. But as you can see from the left here, it says client N and then what they've done. That is all done through this template string. Another function before we get to the main core of the application is a check for existing user. This function loops through the client map and checks that a user is currently signed in or not. This is useful for when checking if a user has already been signed in when you're trying to authenticate another user. Now onto the server. So this is using JavaScript's Net framework, and it creates a new TCP server, and it adds this function here, this entire large body, as a onConnect event handler. So anytime a new client is connected to the server, this entire function runs. It creates a new MeClient instance, logs it to the server, and then adds it to the client map. It then writes to that client a welcome message. This text here is a color character encoding, which gives the colorful output in a normal bash terminal. This next line is adding a onData event handler. So whenever this client process receives data as a buffer, it executes this function. The first thing we do is split the buffer up by each word. So each word is split into an array. We destructure that first word as well as the second two words as the command that the user has typed and their arguments if they are a sum. We execute this as server log, and this is really useful because when we do something like list, you can say executed command list with arguments channels. And that would come in here as executed command, and then the command is list with arguments arg1 is channels, arg2 is undefined. Then we switch over the command and we match it to any of the strings. Let's take for example, the new command. This is for creating a new user. We know when someone creates a new user that they're passing in a username and a password as well. So first we check if those arguments exist. If they don't, we say so. We say missing arguments. Otherwise, we check if the client has already been authenticated. We don't let users who are already authenticated create new accounts. As such, we write to the client, already authenticated, try using something else. Otherwise, we check to make sure that the username is existing within the user store. If the user already exists, we tell the user that they should pick a different username or that they should try to log in instead. Finally, if all of those conditions fail, they get to actually create the new user by adding the username to the user store and setting its value as the password. And then we write a message to the user prompting them to log in with their new account, which leads us to the login command. Again, we check for the arguments if they're undefined. We check if they're already authenticated. We check that the user already exists or not. This is in a sense of them already being logged in. So if I'm logged in as user Ethan and someone else comes in and tries to log in as me, if I'm already chatting on the application, we don't want there to be two people of the same account. So we say username's already logged in. Additionally, we check if the username does or does not exist. And if it does exist, we then check if the username that they passed in is equivalent to the password that was used when they created the account. If so, they've logged in successfully. We set their username on the client instance, and we toggle the authentication to true. Lastly, if that last condition fails, we know that they've passed in an incorrect password, and we tell them to try again. We have more commands here, such as the logout command, the connect command, disconnect command, list, chat, exit, help, and the last command, which is default, which is a catch-all, default bad command. Another fun thing that we have here is the case undefined within the help command. So if you remember, the help lets you learn about all of the commands available. If you just write the word help instead of passing in any other additional arguments, we are able to catch that case here and spit out all the other commands, which is the longest string here. Finally, when that client connection ends and it's disconnected, we have the on-end event handler. We first check if they're authenticated and that if they're connected to a channel. If so, we delete them from the channel and we broadcast the message to that channel if they've left the chat. Then we delete their user instance from the currently signed in users and log the client connection has ended. The last piece of code here is the server.listen event. This is what actually starts everything. When we call .listen on our server instance, it spins up the server we defined. And remember, this very large chunk of code here is executed on every single TCP connection that is created on our application. And so that is how we enable the multiple user chat system. Additionally, with the multiple channels, we store users inside this object, and the broadcast and chat commands iterate over the map of users and send the message to each of those client sockets manually. This server does not use multi-threading or multi-processing, though we do hypothesize that there would be an increase in throughput if each of these channels existed on their own thread, or we used a multi-threaded solution for each of the client connections. The only complication here is when dealing with the channel map logic, it might be difficult for the server to pass multiple operations over multiple threads quickly. Some other things that we've thought about doing and could be great work for future additions to this application include using a more secure user store. So that would mean encrypting the passwords or using an actual database to create the user accounts so they could persist per server instantiation. Additionally, the logging could be easily updated to actually write to a file rather than just console logging it to the into the bash terminal that the server is running in. With these features and more, we imagine our application could be very successful and does demonstrate a strong grasp of TCP connection. I'd like to quickly also show the client that we're using. The client, like I said before, is written in Java. It is an instance of a threaded client class. When it starts, we prompt the user for the IP address and the port number. Then we create a new socket connection, instantiate two scanners, the user's input and the socket's input, and then create a print writer for the socket output. Then we create two threads, a sending thread and a receiving thread. And each thread will run a continuous while loop, checking for user's input or socket's input. When it receives a user's input through here, while true string message equals user input, that next line, when that variable is not null, it will print that message to the socket output. In the receiving handler, we are constantly watching the socket input for a new line, and when it does have one, we print that out to the user. By running these threads independently, or these methods independently, we can have both while loops running at the same time, and thus creating the non-blocking chat application you saw before. And that concludes the code walkthrough and demonstration for my network programming final project. Thank you very much.